Continuing with the topic types of number, today we're going to look at cubes, cube root, reciprocal and primes. So starting with cube numbers. A cube number is a number multiplied by itself and itself again. We can use the following indices to show a value is cubed. So the little 3 here indicates that a value is being cubed. So 2 to the power of 3 or 2 cubed means 2 times 2 times 2. So 2 is being multiplied by itself and itself again. 2 times 2 is 4. 4 times 2 is 8. So 8 is the cube number. Similarly, with square numbers, sometimes people can make the mistake of thinking 2 cubed. This means 2 times 3, which is 6. That isn't the case. Remember, it's multiplied by itself and itself again. It doesn't mean times by 3. Also, like with square numbers, it's the answer that is the cube number. So if we look here, we can see the first 10 cube numbers. So 1 cubed, 1 times 1 is 1, times by 1 equals 1. 2 cubed, 2 times 2 is 4, and then 4 times 2 is 8. So 8 is our second cube number. 3 cubed, 3 times 3 is 9, 9 times 3 is 27. So 27 is our third cube number. And then 4 cubed, 64. Fifth cube number, 125. Then we've got 216, 343, 512, 729, and then finally 10 cubed. 10 times 10 is 100, and then if we do 100 times 10, it's 1000. So, moving on to the cube root. The cube root is the number we multiply by itself and itself again to get the number within the cube root sign. So like with square and square root, the cube root is the opposite of cubing a number, and the symbol for cube root is here. So it's very similar to a square root, but it's got the little 3 outside to show it's the cube root. So for example, the cube root of 125 equals 5, because 5 times 5 times 5 equals 125. 5 is the number we multiply by itself and itself again to get the value within the cube root sign. It doesn't mean divide by 3. It's what number do we times by itself and itself again to get this 125. So if we look here, the cube root of the first 10 cube numbers are these here. So the cube root of 64 equals 4. If we know our cube numbers, we know that 4 cubed, 4 times 4 is 16, 16 times 4 is 64. So then the opposite of that, going backwards, the cube root, or the inverse of 64 is 4. The cube root of 729 is 9, because 9 times 9 times 9 equals 729. So if we look at some examples here, write down the value of 3 cubed plus 2 cubed. Well, 3 cubed, 3 times 3 is 9, times by 3 is 27. So we have 27 plus 2 cubed. 2 times 2 is 4, times by 2 is 8. So 27 plus 8 equals 35. Next, 20 cubed. So with this, I always like to write it out in long first. So 20 cubed means 20 times 20 times 20. So if we deal with the 2's first, and then we can add on the zeros at the end. So 2 times 2 is 4, times by 2 is 8, and then we've got 1, 2, 3 extra zeros in the question, so we can add them into our answer. So 20 cubed is equal to 8,000. Next, we've got the cube root of 1,000. So what do we times by itself and itself again to get 1,000. Well, the answer to that is 10. And then it's being divided by the cube root of 64. So what do we multiply by itself? And itself again to get 64. The answer to that is 4. So 10 divided by 4. Well, when we divide by 4, we can simply half it. So half of 10 is 5, and then half it again to give us 2.5, or 2.5. So moving on to the next type of number, the reciprocal. The reciprocal of a whole number is written as 1 divided by the number, or 1 over the number, so it becomes a fraction. We simply divide 1 by the number. E.g., so for example, the reciprocal of 2 equals a half. 1 over 2. 1 divided by 2, because we know this fraction line means divide. Or that's the same as 0.5, or 50% as a percentage. If the value is a fraction, we flip the fraction to find the reciprocal. So for example, 3/4, we flip it to get the reciprocal. So the reciprocal of 3/4 is 4/3. 4 divided by 3. 4 over 3, 4/3. So some examples on this then. So what is the reciprocal of 5? Well, it's going to equal 1 divided by 5, which equals 1/5, or 0.2 as a decimal. Next, -3. Well, this is going to equal -1 over 3, -1/3. Next, we got 1/2. Well, if we flip that, we know it's going to become 2 over 1. But remember, with a fraction, we never leave the denominator as 1, because this is the same as 2 divided by 1, which just equals 2. Next, we got 0.2. So if we apply the same rule, this means it equals 1 divided by 0.2. But we can never mix fractions and decimals. Therefore, we need to get rid of the decimal on the bottom. In order to do that, we need to times both parts by 10. So we end up with 10 divided by 2, which equals 5. So the reciprocal of 0.2 equals 5. Or the other way that we can look at this is by converting the decimal to a fraction. We know that 0.2, the first number after the decimal point, is our tenths column. So 0.2 is the same as 2/10, which we can cancel down to 1/5, or you could leave it as 2/10. Once we've got it as a fraction, remember to find the reciprocal, we simply flip it. So 1/5 would become 5 over 1, which is equal to 5. As remember, 5 divided by 1 is equal to 5. Anything divided by 1 is just the value that it is. Finally, 4/5, we've got another fraction here, so we need to flip the fraction the other way round. So the reciprocal of 4/5 becomes 5/4, or 5 divided by 4. Moving on to the last type of number then, prime numbers. A prime number is a number greater than 1 that only has 2 factors. 1 and the number itself. No other numbers can divide exactly into prime numbers. So this is where some people can get confused, where they think 1 is a prime number. But 1 only has 1 factor, therefore 1 is not a prime number. So the first 5 prime numbers are 2, 3, 5, 7 and 11. 2 is the only even prime number because every even number after 2 or greater than 2, 1, the number itself, and 2 will always divide into them. So some examples on these. Using only the numbers in the following list, write down 2 prime numbers that have a sum of 32. Well, if we first of all go through the list and then cross off any numbers which are not prime numbers, so to see what we're left with. 10, is that a prime number? Well, no, it's even, so we know that 1 goes into it, 10 goes into it, and 2 definitely goes into it. 11, is that a prime number? Yes. The only numbers that go into 11 are 1 and 11. 12, again, even number, so 2 is going to go into that as well as 1 and 12, so it's got more than 2 factors. 13, again, it's a prime number, only 1 and 13 go into it. 14, even, so we know 2 is going to go into that as well. 15, well, we know that 15 is in the 5 times table, so 5 goes into it. It's also in the 3 times tables, so that can't be a prime number. 16, again, even number, so 2 is definitely going to go into it. 17, well, for 17, only factors for 17, only numbers that go into 17 are 1 and 17, so yes, it's a prime number. 18, even number again, so you know 2 is going to go into it. 19, the only numbers that go into 19 are 1 and 19, so yes, it's a prime number. And then 20, well, we know 5 goes into it, 10 goes into it, but again, it's an even number, so 2 is definitely going to go into that. So 2 prime numbers that have a sum of 32, well, we know sum means add. So 2 numbers that add to make 32, well, 11 and 13 only make 24, so it can't be those. 13 and 17 give us 30, so we're close. So it must be 13 add 19, if we try that. 3 add 9 is 12, 2 down carry 1, 1 add 1 is 2, and the one we carried is 3. So, yep, that must be our 2 numbers, 13 and 19. Okay, using only the numbers in the following list, write down a prime number. Okay, so again, if we go through the numbers, 57. Well, 57 is an odd number as the unit digit is a 7. But a quick check to check if 3 goes into a number. If you add up the 2 digits, 5 add 7 is 12. If that value is in the 3 times table, so the sum of the 2 numbers is in the 3 times table, it means you can divide it by 3. So 57 is in the 3 times table, so it's divisible by 3. It's also divisible by 1 and 57, so it can't be a prime number. 58 is an even number, so we know 2 definitely goes into it. 59, well, 5 add 9 is 14. 14 isn't in the 3 times table, so it's not divisible by 3. It's an odd number as it ends in a 9, so it's not divisible by 2. And it isn't in any of the other times tables, so 59 we can write down is a prime number. 60 is an even number, so it's divisible by 2. 61, again, 6 add 1 is 7. 7 is not in the 3 times table, so it's not divisible by 3. It's ending in a 1, so it's an odd number, so it's not divisible by 2. So 61, again, is not in any of the other times tables other than the 1 times tables and the 61 times tables. So 61 is a prime number. 62, even number, so it's divisible by 2. 63, 6 and 3 is 9. 9 is in the 3 times tables, so it's divisible by 3. Or we can say it's in the 9 times tables or the 7 times tables. 64, even number, so it's divisible by 2, so it can't be prime. 65, well, it's ending in a 5, so we know that must be in the 5 times tables. So it has more than 2 numbers that go into it. So they are our only 2 choices, 59 or 61. You get the mark for putting either of those down. Finally then, a cube number. So a cube number, if I rub these out, we know a cube number is a number multiplied by itself and itself again. So 1 cubed, we know is 1 times 1 times 1, which is 1. 2 cubed, 2 times 2 times 2. 2 times 2 is 4, times by 2 is 8. 3 cubed, 3 times 3 is 9. 9 times 3 is 27. 4 cubed, 4 times 4 is 16. 16 times 4 is 64, which is in our list. So the cube number is 64.